hopefully I can get through number 84 with you. The C is a little bit tricky, but the phase shift, and people have gotten this wrong. All right, but anyway, so let's just try to get it right. All right, so it says, okay, it says write an equation for a function that is given by the following characteristics. For 84, it says it's a sine curve with a period of 4 pi, amplitude 3, left phase shift of pi over 4, and a vertical translation down of 1 unit. Okay, so try to just take my time here. Now, some of it's easy, I think. Amplitude 3, well, that's just this guy, right? Boom. And the vertical shift is easy. It's down 1 unit, so that's -1. Fine. Now, the next kind of thing to get that's got a little bit of, just B. So the book does it B just if you take 2 pi and you divide it by the period, it gets you what B is. And so B is equal to 1/2 because the period was 4 pi, so because it's 2 pi divided by 4 pi, 1/2. Now just think about it. If I put in a 1/2 in this spot, if x changes by 4 pi, then it'll undergo 1 period because 4 pi divided by 2 is 2 pi, which is what sines and cosines repeat themselves. Now, this phase shift, we got to think, okay, what's up with it? In other words, if you look at the graph above, we want the graph to start at pi over 4. So what we're saying is when x is 0, this thing is going to be at that point there. So now the kicker is the period of this thing has been stretched. So we have to sort of deal with the fact that this isn't just your base sine anymore. The period has been affected. So how do you find the phase shift is you put in, we want to shift the graph to the left, pi over 4. So if I put my pi over 4 here in that spot, we know that when x is equal to 0, it'll be the same location as this pi over 4. But because it's been, the period has been sort of stretched out by a factor of 2, you got to put it in this spot where it's in here, because it's where the graph is, the position where it's starting. So Bob's answer to this question is the following, the way Bob wrote it. Now, this is a perfectly good explanation right there, way it's written out right there. But Bob had this, had 1/2 x plus pi over 8, so -1. So it didn't have pi over 4. I was looking at your homework, so everyone had pi over 4. But you have to sort of encapsulate it in this part right here, so that, it's just how the phase shift is defined in the textbook. So this is Bob's answer. Y equals 3 times sine of the quantity 1/2 x plus pi over 8 minus 1. And it all boils down to is you have to put it inside parentheses because B is affecting the period. So to do the phase shift, you have to have it in those parentheses. Now 86, we're using cosine. And so it says it has a period of 4 pi, an amplitude of 3, the right phase shift of pi over 2, and a vertical translation up of 2 units. So some of these things are the same. The amplitude is 3. We use cosine. Now B turns out to be the same as before. Hopefully that makes sense because I'm not going to reinvent the wheel on that one. And then we got x, and I'm going to leave that, and then our translation is up 2 units, so I'm going to put a +2. So now we want a phase shift of pi over 2. So pi over 2 means that the doggy will be right there. It'll start there. So what we want it to do is we want to shift it. We want it so that when x is 0, it's at pi over 2. So if I put in pi over 2 in this spot, now you got to put, once again, you got to put it inside the parentheses because the period's being affected. All right? So there's this. And then the final Bob's answer is equal to cosine 1/2 y equals, I'll make sure I put emphasis on that, minus pi over 4 plus 2. And so that's Bob's answer for that one. Okay, 88. So 88, we're given this expression here. It says find the time for one full respiratory cycle. All right, so the question becomes, what value of t do I need here to make that equal to 2 pi? Well, the answer is 6, because if you take pi over 3 times 6, that's equal to 2 pi. Now, that's how I kind of like to look at it, just kind of, just see what it needs to be and do it. But now, if you want to use the book's formula, b is equal to 2 pi over the period. So the period is equal to 2 pi over b, which would equal 2 pi over 3, which would be 6. So the answer is 6 seconds. Okay, and it says find the number of cycles per minute. Well, if it takes 6 seconds, so this is A, and then B would be, okay, well, 60 divided by 6 is 10. And then it says sketch a graph of it. Sketch the graph of the velocity function. Okay, so what do we got here? So it's just going to kind of, doesn't have any phase shifts. We don't have to worry about that. So it just kind of goes back and forth. Boom. And the highest it goes is 0.85. And the lowest is negative 0.85. And the time for one complete cycle is 6 seconds. So there's the sketch of the graph. Okay, on to number 19. All right. It says approximate blood pressure. All right. It says find the period. Okay, well, the period is where this thing here is going to equal 2 pi. So 5 pi times, and then I can use this fancy little tau thingy over 3 equals 2 pi. So they sometimes use that symbol. Anyway, so we go, so tau equals 6/5. Right? So it's 6/5 of a second. And then how many beats per minute? Well, that would be part A. So part B would be 60 divided by 6/5, which is the same as 60, times 5 over 6, which is 50. Which makes sense. If it takes slightly more than a second to have a beat, then you're going to have slightly less than 60 beats in a minute. And the guy's actually just pretty healthy, too. Anyway, enough said. No, I did 94, so I'm going to just call it a day on this one. And anyways, enjoy. I will send these off to you as soon as I can. Bye-bye now.